assignment 3, do we have to do the envelopes?
Go. All right, so good afternoon, everyone, or good evening, to be more precise. Thank you all for joining us for this talk about the recent work that we have done. That the purpose of this work is not only to show you something that we have developed in terms of research, but also to show you how we can do a lot of work that could be, along with the research part of it, it could be helping developers in real world scenarios, right? So there is part of this is to show you the challenges we are facing when we are refactoring code, okay? Along those lines, you know what refactoring means and how it is important. And then we'll show you a real world example of how we can take a problem, right, from the scratch and develop a solution that comes like what's the idea behind solving this problem, all the way to design, and then even implementation of the solution, okay? You can see how we can take it from just an idea to actual code that is running and can help be developers, okay? So this is the purpose of this presentation. So it's all started back when, okay, here we go. So it all starts when one of the students from SE, he was SE student, right? He came to me one day and he was telling me that he works at Xerox, first of all, so he came to me and he said that he was noticing that whenever he submits a pull request for a refactored code, right, it would take typically longer to be accepted versus other types of changes as fixing bugs, for example, right? And he was telling me this on purpose because he knows I'm a refactoring guy, right? And I like to talk about refactoring. And obviously that surprised me. Why? Because refactoring is by definition the art of changing the source code to improve it without altering or changing its external behavior, okay? So changes that you do to improve the design of your code, right? Renaming, extracting, moving stuff around, cleaning the code, we typically say that, clean the code, right? Is an action of refactoring that the intention of it is to make things better, right? So what makes a refactoring code or refactored code takes longer to be approved by reviewers? That was the question I was wondering. Like, it doesn't make sense, right? That was the claim that this student is telling me. So I needed to see whether this is true or not, right? To do that, what we have done is we took 171 refactoring or pull request refactoring from Xerox repository for that year, and we identified all the code authors, developers who did those changes, on those refactoring requests. We also selected another 171 non-refactoring pull requests done by the same people, okay? And then we compared them in terms of what? How long it takes them to get a decision, either to get approved or denied, right? And also how much discussion happened between the code authors and the reviewers before making a decision, right? And surprisingly, it was true that the refactored code or pull request, it would take longer to be approved or denied, right? Versus a non-refactoring code. And also, it triggers longer discussion between reviewers rather than a non-refactoring code, okay? And this is due to various reasons that we had to go through and manually analyze and come up with some recommendations to whoever submitting a refactoring code on how we can make this faster, right? So if from now on, if you're submitting a refactoring pull request, you have to document it in a way that reflects the following, okay? You may want to, first of all, think about 3 I's, okay, when you do that. The first I is the intent, okay? Make sure to document what is the intent of this, or the what's the purpose of this refactoring, right? Are you removing some dead code? Are you removing a duplicate method? Are you extracting or splitting a large method? Tell me what are you doing here? What's the intent, right? And then tell me how you're doing that. What are the refactoring operations you're performing? Renaming, extract, right? Move, inline, etc. Tell me what exactly the operation you're performing, and tell me what is the impact of that refactoring on the code so that I can assess your change, right? Are you improving readability? Are you reducing complexity? Are you reducing size? What exactly you're doing that I can see how to measure and code improvement, right? So this is our recommendation based on this instruction, because what we have noticed is a lot of developers, the way they document refactoring is very subjective versus how they document, for example, bug fixes, which is pretty straightforward, right? However, when they are documenting refactoring, it's somewhere subjective, and therefore, to reduce some of the bias that they can be introduced, then we have to think about these 3 dimensions, right? So this is our first story, but unfortunately, this story tells us there is a bigger problem coming here, right? So when I used to live in France, back in France, I used to see this sign a lot when I crossed the railroads, right? Anyone can read this?
A train put, I don't know. I know there were trains there.
Yeah, there's a train there. You know, un train peut en cacher un autre. It means a train can hide another one. Okay? Which means that if we have developers facing issues with documenting refactoring, then perhaps this is hiding a bigger problem when it comes to how we can all understand refactoring. Okay? And various studies indeed have shown that there is a problem when it comes to refactoring and usability, right? Developers, they don't know how to document refactoring. Their tools, refactoring tools, are underused. People are misusing refactoring, you know, the usability or not of refactoring. And also, you know, people don't trust automated refactorings. We are still doing the old fashion of doing everything manually when it comes to refactoring, right? So definitely we are suffering from a lack of refactoring culture here. Okay? So one way for us to overcome this is to actually look at how developers perform these actions at the IDE level, because that's when we can understand where things are getting blurry, right? So looking at one of those studies, the most used IDE mentioned by the studies is actually IntelliJ, right? It's very famous. Everyone's using it, right? How many people are using IntelliJ here?
Right.
All right, almost everyone. Awesome, everyone, right? So because of that, right, we decided to collaborate with JetBrains, right, to understand how developers refactor code in IntelliJ. Okay, you see me here, Iman, my student, me, Lee joined us later. So we are all working in collaboration with JetBrains to understand how developers, or even improve now. He's joining the team of improving the tools. But back then we were looking at what are the problems that we are facing when we are refactoring code through IntelliJ, right? So our goal was, again, to understand what are the problems, what is the gap when it comes to refactoring code using IntelliJ. Okay? We ran this long survey of a lot of questions, but anyway, what the purpose of these questions were, tell us how you refactor code, basically. All this is just to say how you refactor code, right? And we had many developers collaborating or contributing to this survey through IntelliJ's platform, and we get the following results, right? When it comes to renaming stuff, if you're renaming a method, class, package, attribute, the majority of developers, 85%, they're actually refactoring it using the IDE. Okay? So this is, for us, this is good news. Right? Because when you do that refactoring using the IDE, you are using the appropriate medium implemented by JetBrains to refactor your code. and there is no risk of introducing any problems or issues, right? But it wasn't as good news as when it comes to extracting stuff, right? When you're splitting something into two, only half of the developers are using the IDE. The remaining, they're still doing things manually. Copy the method if you want to if you want to split something, you copy paste it, and then you remove things here and there, and here we go. You have two different methods now, right? And of course, this is alarming because when you do that, you may introduce problems in your code. It's not safe to do that, right? Even worse, when it comes to moving things around, developers are still cutting and pasting code around the repository, right? And they are not using IntelliJ's built-in features to do that, even though they exist. You can do all these actions using IntelliJ refactoring features. And they are safe, correct, etc., right?
Many are not aware of it, I think.
Yeah, exactly. When we ask them the questions, many of them they don't know about it, just like you said, right? So they said, well, I think it's more intuitive to do just this manually, right? And others say, I don't know like how this would happen. Like, I don't know how this feature would work. Okay? And if you think that these are developers who have been working there for industry for a while, right? Imagine what would be the case for us, students. We don't know that. Same thing. You would expect this to be the same, right? And this is obviously a problem that we have to report to JetBrains. Why? Because they realize that this menu is not working properly. See, you have it already. I mean, everything you have is here, right? Rename, refactor this, change signature, extract, move, pull up, everything. It's just there. But we don't really use it. Okay?
How do you move methods? I also don't know actually. Move.
You can move members, yeah. Yeah, yes, it's all there, right? We are not just familiar with it, right? First of all, because we are raised not using IDEs in the beginning, right? So we have to copy and paste everything ourselves. Plus, to be honest, it's intuitive. To do that is fine, right? But once you start working on a code that is not yours anymore, and you don't know all the methods in there, that's when it becomes dangerous to you to do that. Because that's when you can introduce regression without you knowing that, right? And guess what? That's going to happen in the industry in the future, right? Right now, you're still working on your own code, which is maybe a few classes, right? But once you go to a bigger project, working on a different scale, you're still working on a code that you only know like 5% of, that's when, if you don't use this, you are risking to introduce regression.
What was the phrase you used? Risking
To introduce regression.
Regression.
or regression?
Regression, yeah, because if you are moving things around without properly knowing the whole system architecture, right, which IntelliJ does, because what they do behind the scenes is they generate the abstract syntax tree of the code to see whether your refactoring is performed correctly or not, whether you have the right to move this method here or not, whether there's duplicate of the same method name or not. They will have a lot of checkers that will guarantee that whatever action you have taken is correct syntactically. Semantically, that's a different story, right? But syntactically, it's correct. Okay? So, therefore, we realize that we need to help developers with this, right? And we have to start somewhere. And we decided to start actually here with the extract refactoring, right? So this is just us deciding that, okay, we want to work on this part, as I was explaining earlier. Why? Because we thought that copy and paste is such an intuitive action. Actually, is the most used action if you sum these, right? And this is obviously, it's one of the most intuitive actions developers take every single day. Copy, paste, cut and paste, right? So if we can help developers do a better job with copy and pasting code, then we can help them perform more refactoring and be familiar with this extract refactoring, right? Instead of me asking you to go and figure out how to use the extract refactoring, can I tell you just in time when you are copy pasting code, can you do this refactoring instead? That was the idea behind, and that's when Lee joined the effort of building a plugin that can help us do that more efficiently. Okay? So this is where we started. And one thing that we needed to work on is duplicate code, right? When you are duplicating code, obviously, it's always bad news. However, it's always there, right? So duplicate code is the fact that you are copy and pasting code that is the same and you're keeping it there, in your project, right? And we have so many reasons to do that, which is fine, right? However, we should be aware of these duplicate code, and we should be aware that maybe it's better to just refactor them instead as well, right? So that's why many design principles, they said don't do it, don't copy and paste code and just leave duplicates there. They have a lot of principles, as you can see, and it's considered one of the anti-patterns by several quality gates such as SonarQube, etc. Right? They will say don't do it. They will flag this as duplicate code, right? That's why I consider it a bad practice. Yet, we do have workshops and conferences trying to explain the phenomena of duplicate and why it's so prevalent and so frequent among developers, right? And in this keynote of this conference, which just happened like the beginning of October, so it was like 3 weeks ago, they talked about existing of a large amount of duplicates so they looked at 2.6 million projects, on GitHub, obviously, right? We're speaking of 256 million files, right? And they found a crazy amount of duplicate code among these projects. Okay? And they're talking about this impacting all kinds of things, including anyone who tries to learn from source code. So, bottom line, duplicates, they exist. No matter how much we tell developers don't do it, no matter how teach students don't do it, it's there. And this is in good projects, by the way. It means we're speaking of expert developers still duplicating code nowadays. Obviously, telling them up front, don't do it's not going to work. So can we tell them when it happens, here is a better way to do that? That was the idea behind, the plugin, right? So we wanted to kind of work on creating, right, this segment that when we have similar logic to just join them under one class. And that would be the extract method refactoring. If you copy paste code, right, multiple times, you would rather have that code into a method and then just call that method instead. Same thing. So that's what we want to do. Instead of developers copy pasting code multiple times, we will just tell them, hey, we can make this a method and just replace all these instances with a method call. Okay? So that was the idea behind our plugin. We said, let's build a plugin, IntelliJ plugin, that would help developers better copy paste code by telling them when it happened, please refactor your code into a method. Okay? This is an example, right? If someone copies and pastes this code, right, this code fragment, right, we can tell them, hey, there's an extract method refactoring here you can do. Instead of us expecting them to go to the refactoring menu and do it manually, right, we can right away recommend this to happen. Okay? So our problem here is people are copy and pasting the same code, right? And we want to develop a solution that is able to look at this piece of code, right? And then flag a potential refactoring when it is worth it. When it is worth it means perhaps not every copy and paste is worth refactoring. So we want to only tell developers to refactor their code when this piece of code, piece of chunk is worth refactoring. Maybe it has to be large, it has to be complex, something that is worth becoming a method. Okay, and that was the question here. How can we decide whether a given code fragment is worth refactoring or not? And that is the research part that we needed to do in order for us to come up with that decision. Okay? Because the moment you start asking the developer to refactor every single time they copy and paste, they will no longer do it anymore. Because it is the case, it's true, that not every single copy and paste is worth of making a method, right? However, if you are maybe copy pasting a big piece of code, for example, right, then maybe that's when you should maybe refactor it. So we had to make a decision. How can we make this decision? How do we learn whether this code is worth refactoring? That was the question that we had here. Okay, and this is the anti-copy paster project, right? It's under, JetBrains research that we are developing right now in order for us to be able to, recommend this refactoring, right? So mainly the work that we wanted to work on here. So this is us talking about how we develop this plugin, right? And the main piece that we as RIT students worked in is this model. Okay, you can see us here working on the model with our masks on, because this started back when we still have masks on, right? Started this last spring. Okay, so the question we had is, how can we make that decision? How do we make the difference between a piece of code, whether it's worth refactoring or not? And one way to do that is to look at the history of previously performed refactoring. Okay? If we have a history of developers copy and pasting, then refactoring the code, copy paste then refactoring, copy paste then refactoring, copy paste then refactoring, versus not, right? Then we can learn what kind of patterns exist between all these code fragments that made developers decide to refactor them. So we are learning by example, kind of, right? We look at a lot of examples and we make a decision, we learn from these examples, and we make a decision that whenever we have a new piece of code that shares similar characteristics, then we say, oh, based on our history, we have seen that 1,000 developers refactored the same kind of code that they have, then this one is worth refactoring, right? And when you do that, you are using supervised learning. Now we are jumping into the area of data science, right? We have a lot of examples and you want to find patterns between them, right? So therefore what we have done here is we are tackling this as a binary classification problem. It means we are deciding that for a given input, we have to find some characteristics that will make this input unique in a way to make a decision whether this should be extracted or not, right? Again, to keep it simple, we have a bunch of examples of code that was refactored by developers. And if we have a similar fragment coming to us, we look at this fragment and we see how close it is to the previous ones. And if it's that close, then we decide it should be refactored. How do we do that? We use a lot of metrics. Okay, lines of code, number of attributes, number of operations, number of operands, coupling, complexity, bunch of metrics. We use up to 78 metrics. Okay, so if this code fragment that we are copy pasting right now has similar metric numbers, okay, let's say if it's larger than 5 and complexity is more than 2, then it is extremely similar to the previously one that was refactored. So yes, refactor it. Otherwise, we just keep quiet, right? So building that model, that decision, that's what Lee has been working on as a grad student. Because a lot of students, they come to me and say, well, I'm an undergrad student and I have no idea how we do research here. Here is an example, right? It is, some students think that research is too abstract. No. It's too concrete, right? These are a real problem, right? You take a moment to think about it, and then you have to apply what you have learned to kind of come up with a decision here. And the question here is yes and no. Simple. So what Lee will be doing in a few minutes from now is to show you how we build this from the scratch. It means how the data was collected already by JetBrains team. They have access to the data. They have access to all these copy and paste. They use some tool to collect that data, of course. And then they give us a bunch of code and say, this is what we have. Can you build that model for us? Can you build that yes or no for us? And that's what we did. Okay, so again, this is what they have done, and this is us. Just one component in the plugin. Mm-hmm.
So until now, you're talking about methods extracting, and you have a lot of copy paste of methods or use block of code which you want to break into methods. I'm thinking of refactoring in terms of sometimes you directly implement classes and you want to break them into interfaces. So is that also included in this?
So on the long term, we want to do that, but right now we are only focusing on copy and paste code. Why? Because it's the most frequent action we have seen. We are just working on that tiny copy and paste. That's it. Because if we impact developers on that tiny action, we can impact them in so many ways too. Well, when I did to give you another answer, when I did my PhD back in the days, I was trying to do a lot of brute force refactoring like that, and it was not easy to convince people to do that. So, but if someone is making that action on that moment, it will be easy to say, look, you can do this in a better way. Here we go, right? So now I want to show you maybe a video of how this actually works. Let me go ahead. I'm gonna skip those details of how we collected the data because I don't think we need to know about this. Instead, let me show you how this tool that we have developed actually works. Should we click on the link maybe?
You should just click on the link, yeah. As you were talking about this, IntelliJ is telling me that I have a code duplication. And so as you were talking about it, I was like, oh, how can I pull this out into
Here we go.
different? So,
Here we go.
Let's
Exactly.
see. The audio should come through.
You want to.
Yeah. Or do you just want to narrate instead of do you just want to narrate what's happening instead of trying to play the audio through this?
Yeah, command shift F6,
Are they gonna hear it? I think they can hear it,
so.
right?
Yeah.
Are you on Zoom here or that's?
Oh no,
no.
I'm streaming through here. I think audio should be captured.
All right, awesome. So let's play the video. This song.
Let's imagine that we are writing code
No,
in
it's
the
not.
project,
Okay.
and as it often happens, we now need to copy and paste some code into a new method. We go to the necessary method, we select the code, copy it, and then paste it. As soon as the code fragment is pasted, the plugin puts it into a queue. Since in this case we're not editing the code fragment, after the delay the duplicate remains, so all the metrics for this fragment are calculated and the embedded model makes a decision. In this particular case, the code fragment is rather simple and the model does not suggest to extract it. Now, let's say we need to copy and paste a larger fragment. Once again, the plugin waits for a short period of time after pasting, checks that the duplicates are still present, calculates the metrics, and runs the fragment through a model. In this case, the model decided that the fragment should be extracted, so the user can see a notification in the bottom right corner. When the user clicks the notification, the plugin demonstrates a message that this code fragment can be extracted into a separate method to simplify the logic of the enclosing method. The plugin has several such messages that are based on the metrics of the fragment. If the user agrees and clicks OK, the plugin takes them straight to the built-in refactoring feature. Here, the user can name the new method, select its parameters, and carry out the refactoring. Then, they can replace all the duplicates with the calls to the new method. This way, the code duplicate was removed during the writing of the code, without the need for a separate refactoring session later. However, developers often copy and paste code just to edit it. This is precisely why the plugin implements the delay before processing the fragment. In this case, we are editing the fragment shortly after we paste it, so the plugin will not find duplicates after the delay and therefore will not suggest anything to the user. This allows us to avoid annoying false positive suggestion every time some copy and paste is made to edit the code. You can find the source code of the plugin by following this QR code. Thank you very much for your attention.
I think this is now clear, right? You saw how we copy paste, like in the beginning here, a simple piece of code, like few instructions, which is fine. You have a connection to a database, you could copy and pasting it, or a query execution, and you're too lazy to write this down again. You copy paste that instructions or these instructions, and maybe they're not worth making into a method, right? And this is like the example how the plugin would look and make a decision. So for this piece of code, maybe it was less likely to be refactored by many developers. But when we actually copy and pasted this large fragment, right? That's when this fragment contains a lot of things that were similar, or in terms of metrics, they were similar to what previous developers have refactored, and therefore we actually shown this thing,
Plugin
right?
waits for short metrics and runs the fragment through a model.
And then
In
it
this
will
case,
show this
the
one,
model
right?
decided that the fragment should be
Listen
extracted.
here. And here, that's how it tells you that it's better to refactor this code, because we made the calculation and we realized that this is worth refactoring. Okay, so this is the model that we have developed, and right, we are in the middle of seeing whether this altogether makes sense, right? So therefore, we seek your feedback, right, to see if you can help us see whether this is making sense or not, because this is us building based on our understanding, but we need people to look to maybe set up this or install this plugin, and whether they copy and paste, right, and then decide whether to refactor or not, because they can decide whether to do it or not. It's really up to you. But for us, we can learn even from your actions to even improve our model further. Okay? But before we do that, let us show you how we actually implemented this plugin, or exactly how we implemented this model.
I had a
And
question.
yeah,
How long is the delay you're waiting for?
10 seconds. Around 10 seconds.
Less
or
than
even
10
less.
seconds. It's less. It's only like 3 or 4, I would say, when I was using it. It's
It
not
was
that
3
long.
or 4?
Yeah, it gives you a few moments to
Change it.
change it.
Yeah, okay.
Because if it changed, then it's no longer a duplicate, right?
Mhm.
Okay.
Yeah, excellent question, yeah.
Yeah.
All right, Lee, so Lee will show us how we implemented that model.
Yeah. So I still am a graduate student, and I was working on this problem, and I'm a master student in the data science program. So they came to me and like, okay, you need to make this model right. Here's data. Here's what we want it to do. Figure out what's in between. That's kind of like a classic, ask from a data scientist. So I wanted to walk you guys through like kind of exactly how do you go from, okay, here's like raw data that we've collected to here's how you implement an actual solution and get the results you want. So I have a GitHub set up if you want to look at it later, so you can go through this yourself. I've explained everything kind of in markdown cells, and yeah, we'll get started. So first we can load in the actual metrics that were used. So as we said before, we have this whole slew of metrics. There's 78 metrics plus a binary classification label. So you can see that there's like total lines of code, total symbols, area per line, and at the very end, there's some label. That's a binary label, 0 or 1. So 0 is a duplicate or metrics that came from a duplicate that developers decided not to refactor. And then if you get a 1, then that's the label for, hey, developers decided to refactor this duplicate. So we can kind of learn from like train a model based on human decision making. So we make this plugin that is useful but not annoying, because the brute force way to do this would be to, hey, every duplicate refactor. But then if we do that, users will like get annoyed and just uninstall plugin, and they're not going to use it. So the first thing we need to take care of is there's a large amount of class imbalance, because it turns out there's way more duplicates that people decided to keep rather than to refactor. And this is a problem if we train some type of machine learning model on this, because it's going to learn the negative class examples way more than the positive. So you end up with this model that's like 99% accurate, but that's because it's guessing everything is negative, which will cover 99% of the data. So the very first thing we need to do is we need to balance our classes. And with balancing our classes, which is in this case, we're undersampling the negative class. So we're basically saying we have way too many negative. Let's just randomly sample from this. So positive and negative are the same. So now we have this fair sample that a model could learn from and actually give us a good, decision, not just saying it's negative all the time. And after this, there's some pre-processing that I do and some reshaping of the data because of the model that we're using in particular is going to be a one-dimensional convolutional neural network. So the first pre-processing we need to do is we need to standardize our metrics because our metrics, they span many orders of magnitude. So total symbols is going to be much higher than total connectivity. So even though it's a larger number, that doesn't mean it's a more significant feature than the other one. So in order to kind of correct this possible, misunderstanding from the model, we say, hey, let's normalize everything between 0 and 1. So even though there are some metrics that are bigger than others, they're all going to be weighted the same, or their importance isn't going to be determined just by the size of the numbers. So once that's processed, here's kind of a look at, let me zoom in for you guys, the architecture of our convolutional neural network. So what it's doing is we're going to give it an input vector, or this is a vector of our 78 metrics, and we're also going to let it kind of guess what it thinks the label is going to be. So it's we have its input vector, there's a lot of layers and weights that's going to adjust. You can learn about that if you want to take a machine learning course, but this is just an overview. And then it's going to guess the output, should this be refactored or not? And then based off of that guess, we're going to show it the actual answer, and then it's going to calculate the error of how many things that it guessed correct and guessed incorrectly, and then from that, it's going to reweight its layers in order to minimize that error. So I've given a framework in TensorFlow to build your own model. So here it's defining all the layers, you see them in the diagram. They're also defined here. And so we can make a architecture, or if you want, you can mess around with this and make your own architecture and then fit it to our data. So as I said before, the process of training, it's what we're doing is we're feeding it data and it's learning from basically how many times it guesses wrong versus how many times it guesses right, and it keeps updating itself to minimize that error. So as we look, there's a couple metrics here, but we can look at the accuracy, and every epoch or every time it sees all the data or runs through all the data, we can see that the accuracy is increasing. So this is the learning part of machine learning. With this, I gave us a subsample of the data for portability and just for runtime, because it's just an example. So it's not going to get as accurate as the model in the actual plugin, but it's just showing you the process of how are we using machine learning in the software engineering domain. So now we need to evaluate how good our model is. So one way to do this is have a train test split on the data, where you say here is the training data that you use to update your own weights, but now here's the testing data that you've never seen before. So we're going to use that to test hey, did the actual model just overfit on the testing or the training data, or is it actually balanced? So we can do a quick evaluation and see that the accuracy of this is pretty much the same as when it was training. Where did my screen go? Okay. And then, but that's just doing it once, kind of measuring it once on the testing set isn't really sufficient, because we should really prove the model further than that. So what we can do is what's called k-folds cross-validation, which is basically taking your training data and then partitioning it up into k segments. So in this case, it's split up into fifths, and say, hey, we're going to take one segment out and let you train on 4 segments of the data, and then test it on the same testing data, but then kind of cycle out which fifth of the data is taken out from the training data. So basically, we're giving it different segments of the training data every time it trains, and then from that, we can see if it's overfitting the training data or not, because that means that there is a segment in the data that is more important than the others, which it should be. It should all be balanced. So if we let it run 5 times, which here we can see it's ran 3 times now, and it's getting an accuracy of around the 70s, it's staying pretty constant, which is a pretty good indicator that it's not being overfit too bad, because that means that you can afford to take a partition out and then have the training kind of the same. But it's a more honest way to evaluate our model, because we'll see the accuracy kind of bounces up and down depending on what partition it's seeing, but we should really average that to say what the overall accuracy of the model is. So I've kind of showed you like just a brief of the like machine learning pipeline. You start with data, you build a model, you train a model, and then you validate that model. And I hope you can use this in your own work. You can go follow this tutorial, maybe for some class or something, and use this to solve your own software engineering problems when appropriate. If you have a lot of data and you want to train a model to do something for you. So yes, that's our tutorial. Here's the paper that this came in from. So there's a lot of JetBrains people, and there's us. And then we have some current challenges with the model. One is explainability, especially with deep learning. The model's kind of a black box. So you give it an input, it gives you an output, but you don't really have any understanding of what happened in between. So it's like, why is it making the decisions it's making? Like, we know that people made the decision at some point, but then now the model is taking people's decisions and kind of making and interpreting that in its own way to make its own decisions. And we don't really know what that process looks like. And also there's no explicit control on what is worth extracting. So the model is making these decisions without giving any feedback. And right now there's a team of students working on letting users define kind of their own parameters inside of the plugin so they can determine like what features they want to see that's the most important, because the model won't do that. And now it's kind of time to ask for your guys' help, because this plugin is still in development and we need to actually deploy it to some type of test audience to use, so we can gather metrics and take some survey data to see, like, on the technical level it's doing everything that we want it to, but we need to see, like, on the user level, is this actually being an effective tool? Are people actually using it? Is it making your life easier? So we're gonna send out a link to this plugin so you can download this zip file. It's pretty easy. You download a zip file and then you just put it into your IntelliJ install, and then we'll have you use it for like a week or so. This plugin is also in the background recording your metrics. So after you're done using it for a week, you'll just send us that file that's recording like your metrics so we can look at those, and also have you fill out a survey on like your actual happiness with the plugin. So you guys get to be a step in the development process. You guys get to be kind of our test bed to see, like, is this working before we, give it to the world. And I hope you guys would like to participate in that, especially we had some IntelliJ users here. Hopefully it's going to be really simple for you guys. It's going to put your plugin in. You're going to just code as you are for a week. It's going to tell you when you duplicate code, and then you'll tell us if it's useful to you so we can, tune it. Anything else you want to say?
Yeah, that file that we generate, so it does not record your actions per se or your code. It just records how many times you copy pasted code, just a number, and then how many times the tool tells you to refactor it, and whether you did that or not. That's it. That's all we need.
So ultimately you're using IntelliJ's extraction method or
Yes, correct. Yeah, exactly. So our model, once it detects that this is worth refactoring, it will activate IntelliJ's built-in feature. Exactly. This is how we kind of use that menu now, right? Instead of us telling you go and click on this, we will tell you, hey, click on this button, you'll get that refactoring ready for you, right? So we're trying to simplify the usability that way. Okay. Plus, if you're truly interested in this work, hopefully we have now a senior project working on how can we implement or keep up this plugin working. Maybe you will see this coming as a senior project proposal as well in the future. If you like this work and you want to contribute to this effort, maybe a year or two from now you can find yourself working on this project. Why not? Yep. Any other questions? Mm-hmm.
So you had mentioned earlier that you're currently only or mainly focusing on how developers interact with like the copy and paste for duplicating code, because that's the most common thing you see in refactoring. Is there other ideas or things you're looking at going forward for how you can assist developers in other sorts of refactoring? So I think there was a question like on like more efficient, like duplicate classes or like things like that, things that aren't just copy and pasting but are still common redundancies in code.
The short answer is yes. We have ways to do that. Like, for example, if you are moving a class from one package to another, we have ways to say whether this makes sense or not in terms of coupling and cohesion, right? If, for example, if you're moving one class from one package to another and you're increasing the coupling between these packages, then this is a bad idea, right? Or we can measure all the couplings between the packages and detect which class is increasing the coupling, and maybe moving it to a different package would make things better. Yes, we have ways to do that, right? We can actually support refactorings in so many ways, right? We can detect when a name is the name is not representative to what the method is doing. We can, right? Now the question becomes, when do we recommend refactoring? That's the hard question. If you expect developers to come all the way down and say, I'll wait until the end of the sprint to do that, it's not going to happen because they will be busy with something else, right? So the question is, it's not how we can support developers, it's when. That we realize it's hard. Okay? So yes, we can support developers in so many ways, and we started with the most intuitive action before jumping into more complex kind of refactorings, right? So that's where we are right now. And I can come back to JetBrains and say, look, we were able to do this with copy and paste. Let's do this with something else, right? And then they'll be open to that.
We
And
could
we'll-
secure senior projects for the next decade. Just
And we can have senior projects for the next decade.
Yeah.
And now all IntelliJ's,
Yeah.
refactorings are built or made by an RIT students. Why not?
Yeah.
Okay. Yeah, so it's possible to do that. Yeah. It is possible to recommend refactorings in so many ways, but the right question is when to do that. When is it appropriate to recommend refactoring, so that developers may not get annoyed and say, no, I'm not going to do it. No, right? I don't have time for this, right? They have to see the opportunity the same way we see it. Okay. Any other questions?
I generally use the refactor of extracting a method and renaming method. That's all I use. These two features are the most used features by me
Okay.
and in IntelliJ. So I was thinking about like what else can be more important for me that I can do for refactoring.
Makes sense. So it's always good news that you are using the IDE, because personally I just use the rename. So you're already one step ahead of me, right? It's always good that you use more than just the rename, which is so easy because of the keyboard shortcut, right? It's so easy, right? But instead of you trying to learn, and this is where we are failing as maybe educators, as tool developers, to educate developers on how they should refactor code on the right time. Why not interleaving that with their daily activity and say, hey, refactoring and doing, hey, move method, hey, rename, right? If we can do it in the right moment, right? That's how we can nail that. And we are looking for that right moment, me and Lee right now. If you use our tool and give us your feedback by saying, yeah, it recommended many times, we didn't take it into account, or yeah, I do it all the time, we can learn how to make it on the right time. This is it. We just need people to use it and give us feedback, just like any beta product, right? So that we can tune that right moment. But I'm really happy, guys, that you understood exactly what we were doing. This is awesome. It means you are into this work. This is good.
Ahead of some of the paper reviewers.
Yeah. Some of the people are like, yeah, that's true. Awesome.
Yeah. we'll send out links to the plugin and the survey so you guys can use it yourself and then give us feedback. And should we do we need a list of emails from them or anything, or should it be just totally anonymous?
No, it's anonymous, you know.
Yeah.
We don't need to know who's giving us feedback. You can just give us your feedback. I mean, we just want someone to say, yeah, this is useful, this is not useful. Or we just don't want someone who's practicing the tool and send us that XML file, and we can figure that out ourselves.
Yeah, does in that survey we're sending out, does it have a spot for them to upload the XML file, or like how are we
No.
getting that from them?
Oh, that's a good. Oh, I see, Lee. Okay,
Yes.
that's a good point.
Yeah.
Then I don't know whether Jared is sharing this information. He can, or
Yeah.
you can share your email and just collect that information yourself.
Yeah.
My plan was to just get from you whenever, and with the next like day, like
Yeah.
just a message on, I'll send.
And
it to
broadcast it. Yeah.
Yeah, yeah.
Then have your email.
everyone.
Lee.
We can hit
Okay.
like 1,000 or so people.
Okay.
With the ad, so
Okay.
Yeah.
that'll be helpful.
Okay, yeah,
All
yeah,
right.
thanks. Yeah, you guys are helping us beta test. The entire Society of Software Engineers are going to be kind of our first field we're deploying this in, and I hope you guys enjoy it.
Yeah.
Yeah.
Thank you, guys. Thank you so much.
Thank you.